Robots and artificial life have been science fiction dreams for decades. Well, smart cyber beings are here right now, and they could star in the movies or save your life. A scientific genius builds flying robots. A cyber pioneer creates life inside the computer, and a mechanical engineer brings smart swarming bugs to the military. Ever since robots first appeared in exhibitions and movies in the 20s, they've made quite an impression. Crazy, man-like machines, or a new kind of big green Hollywood monster, they scared the heck out of us. However, since teaching them some manners, robots have done their bit for humanity. Nowadays, they wash our clothes and assemble our cars.
And if there's anything else you want to know about your robot, don't hesitate to give us a ring.
Science fiction always plugged robots as becoming our personal slaves and taking the boredom out of our lives. But the reality is, the most advanced robotics are being designed for the military, and they look nothing like Hollywood's big green monsters. They're smart, small, and stealthy, and they're designed to go where no human can. Deep inside this top-secret U.S. military lab in New Mexico are some of the most advanced robots in the world, and they're designed by this man, Barry Spletzer. He's a scientist whose first claim to fame was getting Gerber's baby food to go in those tiny jars with the minimum of mess. What better training ground for a career in inventing special robots for the American military? Super robots able to outsmart the enemy.
I do consider myself an inventor. I get to come up with new things, try to make new ideas work. I think the term inventor has a bad name in general. People think of the guy with the crazy hair, working in his basement, coming up with Frankenstein or whatever. Inventors aren't like that. I think the name should have a little better connotation than that. I've always said I get my real work done riding my bicycle to and from work and when I'm out at lunch. So I figure if I rode into work, had lunch, and went home, I'd probably get all my work done. Not everybody agrees with that.
With an engineering and Navy background, Barry brings a hands-on approach to his design of some of the coolest machines on the planet. Here in his lab, Barry and fellow inventor Gary Fisher are working on an amazing new generation of robots, inspired by insects. And like most everything here at Sandia Labs, they're designed for work on the front lines. In fact, Sandia National Laboratory sprang out of the nuclear testing program at Los Alamos in the 1940s. Since then, Sandia has been turning out the whole 9 yards of top-secret, high-tech hardware for the U.S. military, including nuclear weapons, spy satellites, and a lot of stuff to scare the average bad guy. Now at Sandia, Barry has a new quest.
Our boss, Rush Robinette, had an idea for a hopper. Supposedly came from fishing with grasshoppers. The idea of making some hops like a grasshopper, but no one knew how to make anything hop like that. And Rush and I went around for a few months on his concept of grasshopper and mine. His grasshoppers in New Mexico hop in sort of random directions. Grasshoppers where I come from hop very directly where they're supposed to go. The idea of getting a hopper to hop exactly in the direction you want is very difficult. The idea of a New Mexico grasshopper where it hops sort of in the right direction and then corrects itself later is a lot easier.
The idea of having robot grasshoppers may also have been inspired by the sudden need to reach people high up in caves, like all those Taliban fighters in Afghanistan. Here, the hoppers could be used to detect gas or explosives, listen in on conversations, or deliver a deadly payload. Of course, that's the theory. Now, they just have to make one that works.
This particular version is just an early prototype, and it basically got about a foot off the ground. And from this, we then went to a hopper that has a domed lid so that when this one would land upside down, it would roll over by its bottom heavy weight.
The problem was they only went about 3 feet up, which wouldn't exactly have enemy forces quaking in their army boots. What's more, if a pebble got under the hopper, they'd lose their way. So they devised a piston-powered model, complete with 2 new rotating arms and a self-righting gyro, which would always keep the happy hopper on track. To give the little beast some oomph, it's filled with a flammable gas, the very thing needed to kickstart a real Olympic high jump record.
You want to burn it, you want to burn it fast, you want to get some sort of explosion, and you want to use the explosion to generate a force that comes down to a piston. The piston pushes directly on the ground. It's a very direct way of converting the energy from the fuel into mobility.
Well, let's go hop them.
Out in the real world, well, the back lot actually, the jumping jelly beans were put to the test. They worked all right. First it was 12 feet, then 20, then 30. These babies kicked some serious dirt. All they needed now was a name.
We tried a lot of names. It had lots of acronyms, but none of them caught on. It was Irma at one time, and it was lots of other names. But for some reason, the name the hopper just caught on, and that's all it's ever been called.
But why go with grasshoppers at all? They don't seem to be the most efficient travelers.
Overall, hopping's a really stupid way to get around. It's very energy inefficient. You're launching yourself into the air and you're coming crashing back down to the ground. Compared to wheels or something, it's a really bad type of mobility. But when you start comparing in small scale, it becomes much more interesting.
Which means small packages can pack a big punch and go places humans can't.
One of the things we thought about hoppers early was for the Marine Corps, for using surveillance, where they could send something through fairly rough terrain without having to go there themselves, have a camera on board, and take a look at what's around without sending one of the troops out there.
The hopper's other secret is its brain. Unlike its insect counterpart, it's no dummy.
These things work together as a cooperative arrangement, in this case 14 of them. These guys have an acoustic ranging system on them. They can find their neighbors. Each one has enough intelligence on board to be able to draw a map of where all the neighbors are. We've done some cooperative swarms where they find chemical leaks, go and find a plume, things like that. So this has got a lot of intelligence besides just the hopper.
Okay, it should be ready to go.
Barry designed the hoppers with onboard compasses and other microcircuitry to regulate their speed and angle so they can keep hopping happily towards their target.
You drop a bunch of hoppers at the mouth of a cave or a building. They can hop in, one after the other stays behind, and they drop off a trail of breadcrumbs. Individual hoppers are the breadcrumbs, and they're able to transmit. The guy in the lead takes a picture and transmits it back through all its friends out the building.
And speaking of buildings, with some adjustment, the standard hopper can be converted into super hopper, leaping 30 to 50-foot buildings in a single bound.
The second hopper, we call the tree frog, is just like the first one, except it has a longer piston. You want to put a surveillance camera on top of a building. You can jump on top of a 3-story building with this. You can get on top to set up a cell phone network. Whatever you want to do with it, you can take payloads to greater heights.
Juggling all these complex ideas in his head, Barry needs something to keep his brain hopping, even when he's at home. But Dr. Spletzer's idea of fun is solving unbelievably difficult 3-dimensional puzzles that makes a Rubik's Cube look like child's play.
It's a second stellation of a rhombic dodecahedron, which means it's got a real good geometric definition to it. It gives you a really good perception of 3D geometry after a while, after a long time.
Then, as a bit of extra homework, just to keep the mind active, he designs and hand-builds unusual-looking telescopes from scratch. He even grinds the optical glass himself.
I like doing woodworking, I like doing engineering design, I like trying to figure things out, and I like trying to come up with really weird inventions. So my telescopes are pretty weird compared to most of them. The biggest single thing I do with the telescope is we go out around town and let people have a look. Most people have never seen the rings of Saturn, the moons of Jupiter, craters on the moon, all those things. So we drag these things out to elementary schools about once a month during the school year. An average year, maybe 5,000 people look through my telescope. It tends to open people's minds pretty well.
Meanwhile, back at the lab, another one of Barry's inventions seemed to be on the verge of mutating into a swarm. Tiny robots so small they could crawl under door sills and monitor bad guys or check for toxic chemicals. But would the military, used to heavy-duty hardware, back the plan? With the backing of the military, Barry developed Marv, the tiniest intelligent robot to date. With a total size of around 1 cubic inch, Marv had serious potential.
This smaller vehicle is Marv, the miniature autonomous robotic vehicle, built around 1996 by Sandia as an example of how small you can make a vehicle, primarily with commercial parts. And also this larger guy, which is one of a swarm of vehicles, a swarm of 50 vehicles used to find chemical plumes, to demonstrate that we can develop algorithms and communications and intelligence in this scale.
Intelligence experts believed Marv could be used for detecting poison gas on the battlefield. So Doug Adkins, whose specialty is building tiny mechanical sniffers, joined the team. Along the way, Marv went through some serious downsizing. Meet Marv Jr. At around 1/4 cubic inch, powered by 2 tiny motors, it's the smallest robot of its kind in the world.
They were interested in making a small robot that would carry a sensor around, and one that they could go in and have it dropped off in a location, and then it runs off and parks itself somewhere and either listens in or detects a chemical odor or something in there. And since we've had a lot of experience in making very small sensors, they thought, well, maybe we can do little small robots. And so we're using the same sort of techniques to make the small robots that we use to make small sensors.
Problem was, no one made parts small enough to run such a tiny vehicle.
The biggest restriction was getting the components and making little sockets for the motors to pop in, and then the tank drive system. These tiny motors were actually made by a Swiss company, and it's actually got a little transmission right in the front of it, so they give a speed reduction. The motor's spinning up to like 10,000 RPM, but it goes through a 2-stage transmission that cuts that down by about a factor of 125. So these motors, I think they're using them in some cameras now and things, but they're very tiny motors that are available, just recently, because they can now make these little transmissions with the very small gears, like 1 millimeter across. Right here is the brains for this thing. This is a microprocessor that you can purchase now. And then there's a clock and a couple of things to drive the motors. So that's basically what there is to it. But this little thing has a lot of capabilities. You can program it up to go on a little mission. You can tell it where to turn, which way to turn. And plus it can keep track of what's going on with any sort of sensor you put on it, and drive its little lights and do the communication out through a radio, all through this one little processor that's right here.
This does have a full computer on board. It has sensing on board. It's a fully autonomous vehicle that'll follow a radio signal. And they're able to search for a plume, a chemical plume, showing swarming behavior and showing that they can share information.
And expanding on the swarming concept laid down by Barry, Doug and his team are developing new jobs for these tiny robots to perform.
So the swarm was a concept that the robotics people here at Sandia have worked on quite a bit. Instead of having one very smart robot, you have several sort of smart ones, and they could communicate with each other. And by passing along information, they kind of like build a whole that's greater than having one very smart one.
They may look fragile, but their tank treads and tiny size allow them to enter dangerous situations and remain virtually invisible.
One of the original scenarios which we saw these things being used is to go on out In a hostage situation where somebody is in a building and you're not sure where they are or where they've got people socked away.
A team of MARV juniors, programmed with vital information and carrying cameras or microphones, could be dropped at small openings, enter buildings unnoticed, and spread out to assess the situation.
So we would like to be able to send in the small robots to park themselves in different locations, to slip into other rooms, and then send back information so we can kind of map out what is going on in that building and where the hostages are, where the bad guys are. Give us a good indication of how to proceed in ending the crisis situation.
Yes, ma'am. Rolo.
So while SWAT teams might find themselves downsizing and replaced by robots, what about the rest of us?
Robots are a long, long ways from being truly humanoid. We have amazing senses that robots are nowhere near having, especially our tactile senses. We're short on computing power, we're short on sensors, and we're short on mobility. You look at a person climbing over a wall, we think the hoppers do pretty well. They do nothing like a person can do. Kind of neat to be able to make something with the motion and mobility of a human or a dog or something like this. I think we're a long ways from doing that. Not that we won't be able to, but it's a long ways off.
Which might or might not be good news, depending on your job. If you're on the front battle lines, the sooner robots can take your place, the better. If Barry can do that, you can guarantee he'll have a lot of very happy customers.
Some of the work we do is really satisfying because we're making the world a better place, a safer place. I think that's really cool. Those are probably the best things we do. A lot of people tell me I have the best job in the world. Folks come in, and I get to invent stuff, get to come up with crazy ideas and try to make them work. It is pretty cool. I don't usually argue with them too much when they say that.
For years, science fiction prepared us for the possibilities of artificial intelligent life. But somehow the idea changed from mechanical robots to thinking computer-generated characters. They live in a cyber world, but are ready to be put to work in movies or video games. What's ahead of us now is nothing short of miraculous. Dr. Dimitri Terzopoulos is a world expert on artificial intelligence, creating some of the first computer-based life forms with the mere touch of a mouse. But think of him as a real-life creator of the Matrix.
I foresee a virtual reality that will be hard to distinguish from real physical reality. So the movie The Matrix, for example, might give a glimpse into something of the sort, where you can kind of have a direct brain interface into a virtual world. My personal goal is to build a simulated virtual world that includes not just plants and animals, but also virtual people that are as realistic as we can make them.
That's a pretty heady goal, but now he's driving a revolution which could change the way we watch movies or play video games. He started the revolution at Canada's University of Toronto in the 1990s. And his brilliant work led to his appointment as the Moses Professor of Science at New York University's Courant Institute. Here in the Media Research Lab, Dimitri and his students create mind-blowing computer-generated characters that can think for themselves. Their software is turning out true cyber creatures which learn and react to their surroundings, just like the real thing. And his students, now spread out around the globe, are making his dream of a Matrix-like virtual world a reality.
What got me interested in applying biological modeling to computer animation is just the need to model humans and animals and plants and all of these biological entities that are a part of our natural world. Our ultimate goal is essentially the holy grail of artificial intelligence and artificial life, which is to produce sentient beings that have all the appearance and behaviors that real humans have.
His goal of building thinking CGI characters begins here with human facial modeling. They're expressive and even interact with each other. And they could have an unexpected spin-off in the real world.
One of the applications that we're pursuing is how we can use a model like this in craniofacial surgery simulation, where you can cut the skin and sew it back up again as a simulator for craniofacial surgeons so they can practice their skills.
These 3D face designs could also be used to predict how people might look after plastic surgery. This could definitely be popular in Hollywood. Not surprisingly, the next step, designing a computer-generated cyberhuman that could learn along the way, proved tricky. So they started off on lower life forms, snakes and fish. They wanted these animal creations to actually learn basic movement, look for food, and even find a mate. In short, learn the art of survival. Just think what a quantum leap that would be for the video game industry. No more pre-programmed dummies. Dimitri's computer creatures are like newborn children. They've got all the muscles and bones needed for life, but they have to learn to use them. So he sends them to his virtual survival academy. Here, the snakes are learning how to slither.
And the learning process is basically one of trial and error. And the snakes are actually trying various different things. The ones on the left begin by trying simple things such as twitching their muscles. And this allows the snake to first of all discover the natural serpentine movement until at the very right, you could see that it has become a very effective slithering machine.
Yellow dots out.
Next, Dimitri and his students wanted to build an entire system of autonomous creatures, and in this artificial fish tank, fish were broken down into predator, prey, and pacifists. Built on complex mathematical formulas, each of the fish had their own basic behaviors, like hunting or mating or crash avoidance. And once started, the fish's ever-changing interaction created a true undersea world.
Each of these fish swims on its own and is aware of itself and its environment.
Here, fish locate tiny white pellets of digital food and have a pretty normal fish life. But they don't age, and the aquarium doesn't need the water changed. So this system could literally sustain itself forever. But now it was time to get back to work on the virtual human, a sort of smart G.I. Joe who could solve real problems. Meet Duffy the Merman.
And the merman was pitted against a shark, which was larger and faster swimmer than the merman was. So now the merman has a problem. How to evade the shark? The shark really just gets interested in things that it's able to see. And since it's hungry, if it sees the merman, it'll chase the merman.
And as long as our merman is out in open water, he's a dead duck. There's nowhere to hide, and he makes a quick and easy afternoon snack for the shark. But when a few rocks are added to the equation, brainy Mr. Merman is able to change his strategy.
The merman hides behind a rock, the shark quickly loses interest. Just as well, the merman has vanished, so it goes to the last place it saw the merman, and if it's still not there, then it loses interest and goes looking for food elsewhere. So the merman is able to evade the shark by essentially trying to stay out of sight.
Although Mr. Merman Meets Jaws is only a demo, its computer software could soon find itself into your favorite video game. Now that'll up the stakes. At last, the bad guys will have a brain, and there's no telling what they'll be capable of. Meanwhile, Duffy continues to pit his wits against the shark, now trying to escape by swimming towards another set of rocks.
When it gets up there, the merman finds that there's a narrow crack in the rocks that he can slip through, but the shark cannot. So this is, again, another problem-solving demonstration on the part of the merman. We kind of started with a virtual human that was half human and half fish as a kind of an intermediate step towards humans that could work in terrestrial environments. And that sort of allowed us to avoid the issues of balance initially.
If thinking CGI humans were really going to work in video games or the movies, then balance and movement become all important. But when Dmitri and his former grad student, Dr. Petros Faloutsis, began addressing the problem, they came up with a whole new concept: virtual stuntmen. This they could take to Hollywood. What could be better? Indestructible digital actors who don't bleed or break bones and don't ask for danger pay.
I have something to tell you.
Have the real stuntmen jumped their last jump? UCLA is but a stone's throw from Hollywood. Where better for Dimitri's former student Petros, now a professor himself, to be creating virtual computer-made stuntmen, which, with the click of his mouse, will escape any hazard or Terminator.
We will see the virtual stuntman replacing real stuntmen in dangerous stunts, so taking away the element of danger for real stuntmen. If we want to have a person fall down a building, we can throw a virtual person do that, and then we can really take a good close-up of the motion.
In stunt acting, people get hurt. And there's certain things that stunt actors will not do. For example, dive headfirst downstairs or jump off a tall building without any cushion on the ground. But a virtual actor can do all these things potentially because there's no one to get hurt. And the task there is to make the modeled actor realistic enough so that they can replace real human actors.
However, stuntmen are more than just skeletons. Now, Petros and his students are fleshing out their virtual heroes. Based on real actors' performances, they're trying to add a hint of character, testing facial expressions that pinpoint emotions.
You didn't even help me. You didn't even help me. I have something to tell you.
As the virtual stuntman becomes more sophisticated, we can see him become a real actor that can be directed just like a person. You can tell him what you want to do, and he will add his own flavor depending on how he's programmed, what his particular style of motion is.
So with emotions they control, these virtual actors are a real quantum leap forward from previous computer-generated or CGI actors in movies like Toy Story.
People are getting used to the idea of CGI characters in the movies nowadays. So people have a tendency to ask, so what's the big deal with virtual characters anymore? Well, I think it's important to distinguish the virtual characters that you see on the screen, which are hand-animated characters. For example, it's been said that Toy Story required 200 person-years of effort to produce that feature-length film. What we're trying to do is actually make self-animating characters, characters that can control themselves, characters that are much more like virtual actors rather than virtual puppets.
If they can fall downstairs, get hit on the head, and react as a human would and not complain, it sounds too good to be true. No doubt human stuntmen will be getting their walking papers soon, but there's one small problem.
In the future, we will have these intelligent creatures. They will have to some extent, a mind of their own, and we'll have to deal with it. There might be a case where the virtual actor really reacts like a human, in the sense that it gets angry, it gets offended, it has an ego.
No one will believe your story.
Virtual characters with attitude? Maybe this isn't going to be as straightforward as Dmitri and Petros thought. Who's going to control these cyber stuntmen? Who gets penalized if they do or say something inappropriate?
Who puts restrictions on the abilities or the thoughts of these virtual characters?
Well, perhaps like Frankenstein's monster, the virtual humans and creatures will ultimately be the responsibility of their creators. But remember how that story turned out.
I've never been accused of having a God complex or being a mad scientist. Although people wonder where this is going in the long run, whether we will be able to actually produce artificial life which maybe threatens real life. Nothing that we're doing now is dangerous. But I can imagine that in the long run, when you get sentient, artificial, virtual life forms, that we will have to, pay attention to them more and more, and eventually maybe even become concerned about them and what they can do to us. Hopefully they will be generally benevolent as opposed to threatening.
No one will believe your story.
They're the ultimate James Bond gadgets, smart flying machines that can swoop under enemy lines, take surveillance pictures, fly into chemical or nuclear disaster sites, and save human lives. Unmanned aerial vehicles have been Professor Robert Michelson's pet project for years. But UAVs are not radio-controlled model airplanes. They're machines with a mind of their own that can think for themselves and make a plan to achieve Mission Impossible. They come in all shapes and sizes, some even based on insects. What's more, they'll fly anywhere, even on the surface of Mars. Since the 1980s as head research engineer at Georgia Technical Institute, Professor Michelson has been creating all manner of flying gizmos for industry, the military, and even NASA. But it's been smart flying robots that could think for themselves that have always fascinated him.
A lot of people have done a lot of work on robots that crawl and roll around on the ground, but not a lot of work had been done in the area of robots that fly. It was a brand new, wide open area. And since I also had an interest in aviation, I decided that the type of robots that I would focus on would be flying robots.
And these small, self-sufficient flying robots, built for the military as stealthy surveillance aircraft, would keep Robert busy for almost 20 years. This flying wing, called Dragon Eye, was built for the Marine Corps. It uses a catapult to take off, and running on its own brain power, will fly over battle lines using radar and other high-tech systems to survey enemy positions.
And I like to think of it as kind of like science fiction. A lot of people read science fiction and enjoy science fiction, but I get the opportunity to live science fiction because I can actually create the things that people only read about.
Robert has lived a science fiction dream since he was a boy. Then, as leader of the high school rocket club, he made flying machines and explosive devices for fun. Ever since, he's been following much the same dream.
We used to take garbage bags and build fires under them in the winter and make hot air balloons. I guess when I was younger, I built a flamethrower. I remember my neighbor called my mother saying, "Your son's out on the side of the house and he's shooting flames 30 feet. We would just put missiles together with warheads on them and launch them. Anything that you could make that would fly was intriguing.
Maybe Robert remembered the fun he'd had as a kid with his science adventures when he began a scheme creating a unique opportunity for engineering students around the world to work on this new technology.
They'd be next in line.
It would be fun, but serious fun, featuring robotic aircraft programmed to carry out a tough set of tasks. In 1990, Robert started the International Aerial Robotics Competition. He brought together young people from far and wide to test their unmanned aerial vehicles in real-world situations. To begin with, it was a matter of getting the darn things airborne and keeping them up. But the first real mission, designed by Robert, was to move a metallic disc across a field. Now, this might seem easy, but it's not, because remember, these are not remote-controlled toy planes or helicopters. They're flying computers, programmed to carry out complex tasks entirely on their own. And it took 5 years before a team successfully moved the disc.
So we wanted to be able to advance the state of the art in aerial robotics by having machines that could do things that were currently impossible. And so we posed various missions to the university community around the world to see if it would be possible to do some of these missions. And surprisingly, to the chagrin of some of the pundits, The students have been able to knock down these impossible tasks in fairly short order.
By the second mission, in the late 90s, the students baffled military experts by getting their autonomous robots to find imaginary toxic waste dumps, map the terrain, and bring back samples. On the third mission, they were able to successfully search for survivors in a set-up search and rescue scenario after an imaginary asteroid strike in Western Europe.
The idea is that the first responders to go into this area to get the survivors would need to know where the survivors really were so they didn't waste their time picking up a dead body and risking their own lives getting in there.
The robotic team's assignment was to have their UAVs avoid hazards and correctly identify survivors from the dead bodies lying about the disaster site. Year after year, teams returned until one finally succeeded. They found the survivors.
And we had a team from Europe that was able to do all aspects of the mission in about 4 years.
While they began with just a handful of competing colleges in 1990, by the millennium, more than a dozen schools came each year. It's to Robert's credit that despite the pressure to succeed and push the technology, these students from around the world maintain an impressive spirit of cooperation throughout the competition.
This isn't about my school versus your school versus one country versus another. This is about sharing ideas and really innovating technology to the point where we're breaking the limits of anything that's ever been done before. So, I mean, this is not a cutthroat competition.
You would act like if you come walking, you're trying to find a phone booth.
What's going on?
Robert's student competition continued to drive the development of the aerial robotics field. And by 2001, a video outlining the fourth mission was sent to colleges around the world. The students and their robots now faced a series of global disasters and challenges worthy of James Bond.
The idea now is to have a robot that can come in about 3 kilometers, identifying one building among several, and then actually either flying into the building or sending a sensor probe into that building to find a specific target.
This year's competition is being held at a military site. Once again, Robert devised the test, and he wants to see if any of the groups can conquer his latest challenges. The students' mission is to get their flying robots to identify one specific building, marked by the event's insignia. The idea is aimed at situations in the real world, identifying a problem building at a disaster site, or perhaps even the location of injured people inside, after which an even smaller probe could be sent in. This year, one of the UAVs locates the correct building on its own.
When you see the machine go and all of a sudden change direction and do things like that, it's thinking for itself. And that's why this is a higher level of robotic behavior than you normally find anywhere else. There's a lot of the government military air vehicles they say are autonomous, but really that just means they can fly from here to here to here without anybody at the controls. But they're not really interpreting their surroundings and making decisions on whether they should go here or over there based on what they're seeing on the ground or some other external information. That's what we're doing here.
And despite what this looks like, these unmanned aerial vehicles, UAVs, aren't just intended for military spy missions. They really could save lives.
This kind of technology can be used, for example, in one first thing that comes to mind is something like Chernobyl, where you had a lot of helicopter pilots, manned helicopter pilots, who actually went out to scout the area. A lot of them have actually already died. They died a long time ago because the fact that they went in manned. And you could have done exactly the same thing 10 times over with an unmanned vehicle with no casualties whatsoever.
Yeah, well, we do the same thing. We'll have a wrap-up meeting with the teams at the end.
But now, Robert has one more problem to solve. How to downsize a flying robot into a super light micro-air vehicle, maneuverable enough to get inside buildings. And it's going to take all of his ingenuity to solve it. Robert's contract to develop a stealthy micro-air vehicle came from the Department of Defense, who was looking for smaller, smarter versions of the drones they were already producing. Of course, the idea of pilotless military aircraft isn't new. V-1 rockets were used successfully by the Nazis in World War II. Basically flying bombs, V-1s were anything but smart. But in 2003, the world became aware of U.S. flying Predator drones when one killed several members of Al-Qaeda in Yemen. Since 1996, Robert has been working on the creation of micro-air surveillance vehicles for civilian and military use.
It seemed that the real niche for these micro-air vehicles was the indoor application, because there were no other assets that could rapidly penetrate a building or a bunker and be able to get a sensor deep within the building. So that was the genesis of the idea of an entomopter.
The entomopter, a far-out mechanical flying bug that could get into buildings and fly through halls at slow speeds. But what kind of bug would do the job?
We then teamed up with the University of Cambridge, who'd been studying Manduca sexta, which is the hawk moth or the tobacco hornworm. And the insect happened to be an adept flyer and was in about the size range that we were looking for. So the entomopter wing grew out of that.
It seemed like the concept had potential, and Robert built a mock-up, a paper and string rubber band version of the tiny flying machine, to see if it would actually work.
Oh, this is really rough on the fingers, holding it this tight against the rubber band.
Despite Robert's crippled index finger, the test model was a raging success. Now, there were just a few loose ends to tie up, like controlling it.
The problem of making something that was manufacturable still faced us. How are you going to make a wing flap harder on one side or flap over a bigger span or have more twist while the other wing was not doing that? It becomes mechanically quite complex to do that.
But figuring out a way he could get the mechanical bug to fly like the real one came from the unlikeliest of sources, a cup of tea.
To make it manufacturable, we had to take it beyond creation and use some engineering techniques referred to as circulation control or the Coanda effect. And most people have experienced the Coanda effect, whether they realize it or not. Every time they pour a glass of tea very slowly, they'll notice that the tea doesn't just pour out. It'll wrap around and run down the edge of the glass. And it turns out by emitting a small amount of gas out of the wing of the entomopter, we can cause the flow over the wing to stay attached to the wing, much like the tea is staying attached to the side of the glass. And as long as the flow is attached to the wing, it's generating lift.
So far, a full-scale entomopter here on Earth has yet to fly over the land. It's too heavy, and Robert's waiting on further funding to shrink it down to a lighter weight. But with features like chemical muscle, a gas propellant, and a unique wing design, it wasn't long before Robert's flying insect won a patent and a top scientific design award. That's when NASA came into the picture. The entomopter was the very thing they were looking for. Now it looked like Robert's sci-fi dreams were about to become a reality. In the first year of the new millennium, NASA decided to back his flying robotic insect. As shown in this simulation, the plan was to pack the bug into a high-speed spacecraft with a one-way ticket to the Red Planet. Getting there is only half the problem. Once unpacked, most flying vehicles have trouble staying afloat in the thin Martian air. But not Robert's entomopter. With its size and high-speed flapping power, this is one qualified bug.
Mars probes that have been sent up thus far have involved vehicles that only move across the surface, and very slowly at that. So it would be nice to have a vehicle that could fly over the surface of Mars. But one of the problems is that if you have a traditional fixed-wing flying vehicle, it has to fly extremely fast, over 350 kilometers per hour just to stay in the air. You fly any slower and you fall out of the air. Well, since the entomopter's wings in essence flap at 350 kilometers per hour, The fuselage can move relatively slowly, which allows you to do certain types of science missions that are difficult or impossible to do when you're flying at a very high speed over the surface.
Like nifty mechanical dragonflies, these slightly larger Mars entomopters could run mission after mission on the planet's surface, beaming back video of the landscape and geology. But how near is the project to becoming a reality?
The terrestrial entomopter is about 3 years from production. The Mars entomopter could be 3 to 4 years from production, but you have to build space-qualified hardware there, so there's a little bit more involved to look at the use of the entomopter as a Mars surveyor.
Of course, there's still a few technical odds and ends to tie up before we're all buying a fun-filled entomopter kit at our local Walmart. For now, Robert's mind is busy working on getting the bug completed. But it's here at his home in front of this aquarium that our accomplished inventor gets his best ideas. Robert designed and built every aspect of this tank. It's an engineer's dream. With specimens he personally collected from around the world, it's a complete tropical reef ecosystem, carefully crafted with godlike precision.
It's a computer-controlled aquarium that takes care of water additions, chemical additions, all of the lighting, everything that's required to maintain the various life forms that are in here. This section in here is the computer control for all of the pumps, the lighting. These are ballasts for the metal halide lamps that simulate the sun.
Okay, so he's recreating the sun, the ocean. We know he can make things fly. What's next on Robert's agenda?
I guess the aerial robotics is a way to look at artificial life. I'm looking at real life in many other areas. Now I'm acting as creator myself to try and create my own life forms, as it were, by creating robotic insects and intelligent machines.
From the boy who wanted to fly rockets to master of the aerial robotic universe, Robert is looking forward to the day that one of his creations, the entomopter, is skimming over the surface of Mars.